Hello, everyone, and welcome back to another video in the lecture series for programming implementation for various cybersecurity fundamentals. In this video, we are going to be talking about the implementation for the demo of SQLI attacks implemented in Python, right? And also understand how to protect our databases from such attacks, okay? So to give you all an overview of what we are going to be doing in this implementation, we will essentially write a program in Python, which will essentially be a web application, a minimalist web application, which will, first of all, implement a web server, okay? And this is going to be implemented as a very minimalist front end and back end. We're not going to be doing anything too substantial. We're just going to be implementing the functionalities that are required in order to get our program running such that we can actually see how SQLI attacks actually work and then what needs to be done in order to protect our programs to prevent such attacks from happening, right? So we will implement that, and that web application will essentially consist of a very simple homepage, right? So anytime you load a web application, the first page that you see is known as a landing page or a home page, right? So we are going to develop a very simple home page, and the functionality that will be present on that home page will be in the form of a login web form, which will have two fields, one to allow the users to enter their username and then the password, essentially, right? So it's going to be like a very simple login form. In addition to that, we will also simulate a database server. In class, we have discussed about many different vendors who provides us with database servers in the form of MySQL. We have Oracle database, we have Microsoft SQL Server, and many more options are there, right? So we are going to simulate a database server. So what that means essentially is that we are not going to be implementing an actual database server itself, but we are going to be using something that we call as a SQLite package, okay? And an SQLite package is, even though it is considered to be a database, it is a file-based database, right? So it's not actually, in reality, it's not a database server in itself, but like a prototype of a database server that supports SQL operations, right? So it supports the structured query language. So it's pretty easy to set up. It's straightforward to implement, right? And it supports SQL. So that allows us to kind of, pursue our development using the SQL language. And as a result, we can even check out how the SQL injection attacks work in Python as well, right? So when we create that SQLite database, for simplicity, we're just going to be calling it a database. Please remember that this is basically a file-based storage, and you will see when we implement it what it looks like, right? And then once that database is created, we are going to insert some mock data into that database for demo purposes to understand how things work. We need some entries within the database itself. Otherwise, the actual demo will look a little bit, it will be difficult to implement and show you what it does, right? So we're going to create some data on our side, insert them to SQLite, and that data is typically going to be in the form of a users table, which will store two columns. One of the columns will be for username, and the other column is going to be for password, okay? So very simplistic database, and we will just have 3 or 4 entries within that particular table, okay? And then we will test case for the SQLI attacks. So essentially, we will first implement a program which will be vulnerable to SQLI attacks, and we will test out some of the attack test cases, like the typical type of inputs that an adversary can provide in order to exploit the vulnerability that causes SQLI attacks, right? And then once we understand that, we are going to be fixing the vulnerability by updating our code and then changing the code that actually results in the vulnerability. We address that, and we modify it into something that will be secure from SQLI attacks. And then we will check again, make sure that SQLI attacks are unsuccessful. from the previous checks where it hopefully will be successful, and we will see how that goes. And then overall, any type of debugging that we require, we will debug as needed, because I have an inclination that we will be facing a little bit of a error, because we are essentially doing even though it's a minimalistic application of it, but we are still implementing a full stack web application at the end of the day, right? So this is not going to be similar to the traditional programs, the Python scripts that we have written up until now in the previous demos that we have seen. So it will be a little bit more than that, right, in terms of the implementation, because we need a proper interface. We could have skipped the interface, but it wouldn't have made much sense, because then it will not emulate the real world scenario as such, right? So we will debug as needed as we move forward, right? So looking at what are we trying to simulate, essentially what we are implementing is that there's going to be a full stack web application. So a full stack web application in a practical scenario can have typically these different components. So it will have some sort of a front end, which will act as a user interface. And this will be deployed to essentially the computer or the device that the user is using in order to access the web application, which will be hosted by some sort of a backend web server. And there will be an application server that you can separate or host it on the same machine, right? So that depends on your development choice. So web server essentially is responsible for receiving the request which is being made by the user through the front-end UI. So any type of user request that is being made first comes to the web server. So the web server is always listening on a particular IP address and a port number. It's a service, right, which is made available over the internet. And once the web server receives it, typically what happens is that the web server then forwards that request to the application server. And within the application server, we have the programming logic that is written, which will be executed depending on the nature of the user request that is received and then forwarded to the application server. So for example, if let's say you have an e-commerce website, right, like Amazon.com or Target.com or Walmart.com, something like that, right, and the user is trying to log in, then the whole process of logging in is one functionality. So that will be implemented as a function within the system that is hosting the application server. So when that request of login is received by the web server and thereafter forwarded to the application server, then the application server will essentially identify that request, understand that, right? You will implement it accordingly, and then it will execute the function which is responsible for facilitating the functionality of login, right? Similarly, if the user wants to see what are the items that are currently on sale, right? So that will be also in the form of a web request received by the web server, forwarded to the application server, and then the application server will identify the proper functions within which you have written the code on how to handle that particular request, right? So then it processes that particular request and then it sends a response back. Now, many a times, in order to process certain requests, the application server would require to query the database, right? It will need to either register some new data that is being sent by the user. So let's say the user is trying to, let's say, create a user account, right? So that will be a new entry into the database. So then the application server might need to register that information so that it is permanently stored within your database, right? Your actual physical database. Or at times, the user might be making certain requests which require some sort of a verification, which might be pre-stored in the database. And then the application server essentially requires to query those data in order to verify that whatever information that the user is providing, whether the application already has that information stored in the database, and thus it can essentially validate that whether or not the information provided by the user is actually correct or not, right? And that kind of interaction typically happens when a returning user is trying to, let's say, log into the server. So that means you have already registered the user, and that detail, let's say for the sake of simplicity, we assume that is stored inside the database, and then the application server can check the inputs that are provided by the user in the form of their username and password against whatever is present in the database. Okay, so that could be in the form of secure hashes with salt for the password and the username that is stored within the database, and situations like that, which we have already discussed when we did the demos and the discussion for authentication, right? Secure digital authentication. And in order to facilitate the communication of the application server with the database, essentially we have a database server running on a different system, right? It is good for security best practices to kind of isolate all these servers from each other, so that if any type of compromise or issues attack happens on a particular server, it does not, in a cascading way, like a domino effect, impact all the other servers that are run, right? So typically in a practical scenario, we separate the web server from the application server, and then from the database server. And these are all running on their individual systems, like actual physical separations are there between these servers for security purposes, right? And the database server, what its role is that when it receives the requests from the application server, it can essentially understand what is being, asked by it, and then translate that and then query the database, and then the database grabs the information from it and then returns that information back to the server, and then the server processes that return data, whatever the nature of the response is, and then finally it makes it more presentable for the end user, and then sends back the response, which is then received by the front end, and there is code logic which knows how to represent that information that is received from the server, and then the user can see it in a more readable and user-friendly format, right? So for our use case scenario, the front end will essentially, as I discussed, will be a very simple web form, and the web form will be for login information. So we have the assumption that the users are already registered in the database, right? So we will create some mock data and we will store that inside the database in the form of various username and passwords, right? Anytime a user makes a request to the backend web server, we call that as a HTTP request, right? So HTTP is the protocol for communication over the internet, right? So anytime a data packet is communicated from the front end to the backend, we refer to that as an HTTP request created by the user, right? And that is being sent and received by the server, and then server does its stuff. And whenever backend server sends a response, we refer to that response as an HTTP response, okay? And then when the server receives the HTTP request, it will unpack that request, formulate some form of a database query. So remember, there are two options we have with respect to where we want to formulate the query. The first option is we run it on the database, the backend server itself, or the application server itself, which is a little bit faster in terms of implementation. The other alternative option is that we can formulate the query that will be run against the database on the database server itself, right? So there are two options that are there. Regardless, essentially what happens is a query is executed against the server. Some results in the form of a response is given back to the backend server. So that could be in the form of, let's say, if you're looking for something, like it's like a search request based on certain conditions or parameters, right? So let's say if a user submits their username and password, you want to check if that user is already present in your database or not, and as such, you want to check whether they are a registered user and whether they have provided the correct username and password. You want to authenticate that, right? So the results returned by the database server after executing the query would be in the form of, yeah, I found it, everything looks good, or basically, information not found, right? So that is basically the practical scenario that we are trying to simulate here, right? Now we have to make certain simplifications for our implementation here, because we don't want to do like a full-fledged web application right now, just to understand how SQLI attack works, right? So we want to create a prototype, a very toy application for a full stack web application. So what we are going to be doing is this whole stack, application stack here, or the software stack here, which we said that you can have the backend in a machine, the web server on a particular physical machine, an application server on a separate machine, the DB server on a separate machine, and the actual physical database is somewhere else. We're going to combine this, and we are going to implement all of these different software stacks on the same machine, which in this case would be my local system. And when you implement it, it will be your local system, right? So our web server, application server, database server, although we don't have a proper database server to implement in this particular case, as I discussed, that the option that we will be using to implement the database will be a file-based database. So there is no server per se that it is running for the database services, but we can think of it as something that can be replaced by an actual database server in a realistic environment. So it serves the purpose, right, of what we are practically trying to emulate, the behaviors that we are trying to emulate. So again, all of these 1, 2, 3, 4-ish services, this will be implemented on a single system, which in our case would be our own local system, this machine where we are going to be implementing. Okay. The other aspect is the user will not be accessing this particular web server or trying to access this web server from a different machine. Again, this will be accessed from our own machine itself. So basically, our local system will be acting both as the backend as well as the front end, right? So once this system is up and running, this side of the framework is up and running, we will open a web browser on our local system, and then we will basically type the IP address, which will be our local host, right? And then the port number on which this web server is basically listening to any type of input that might be received or that might be sent by the user, right? So essentially, we will test the application on this local system itself. So to boil it down, we are going to be implementing all of these different stacks and then testing and validating whether it works from our own local system itself. So that is something that you have to keep in mind. But realistically speaking, you would have a scenario where all of these stacks are hosted on different physical machines for secure architecture purposes, and then the user might be on a different network altogether, and there will be a domain name that will be associated to the web server instead of typing IP addresses and port numbers. And the DNS servers can essentially map those URLs. So instead of writing something like 172 point 196 point something, right? Like an IP address and then giving a port number, in a realistic scenario, a user will be writing a URL, right? Like oakland.edu or amazon.com and stuff like that. So that will be internally, there are domain name servers that are present on the network, on the internet, and when they receive those requests, those DNS servers essentially map that to the appropriate IP addresses of the physical systems that are hosting the server, which is nearest to you. And that is how the requests are essentially routed, right? So we won't be doing any of that. Everything will be kind of integrated or present or abstracted within our own local system. So that is something that you got to keep in mind, that what you're implementing is a set of stacks, software stacks, that helps us to implement the full stack web application. And all of this development is going to happen on our local machines itself. Okay. So we need we can implement it from scratch, but having what we call frameworks to implement full stack web applications is something that makes the process of implementation a little bit more efficient, right? What I essentially mean by this comment is that in order to express certain functionalities, you would have to write the code for it in most of the traditional programming languages, which are functional in nature, right? So to understand what I'm saying is that there are two different categories of programming languages that you can think of. One, we call it as functional programming languages, okay? And then there is another category of programming languages which we call as non-functional programming languages, right? So programming languages or coding languages that we use, such as, let's say, Python or C or C++ or Java, right? JavaScript and many of these languages fall into the category of functional language. Whereas there are other languages like the structured query language that we have discussed in class. These fall into the category of non-functional languages. Now, what is the difference between functional and non-functional? Essentially, what it boils down to is that, let's say you want to implement something, right? So there is a logic of what you are trying to implement. So let's say if you're doing secure digital authentication, there is a security logic of the program that needs to be implemented. So essentially, you need to express what are you trying to implement, right? Please excuse my typos here. And when you are expressing what you are trying to implement, you also have to express by yourself how it will function, right? So like how it will work or how the implementation will take place. So you have to write every little detail that is going to be associated for your program to execute properly with the correct logic. You have to write all those details, right? Whereas in non-functional programming languages, in terms of logic, you just have to specify what are you trying to implement, right? And you do not need to specify how that needs to be implemented. So for example, let's say you want to grab the names of the student from the student tables where the student have a GPA of greater than 4.5 or well, 4, 3.5 or something like that, 3.5, right? So essentially that's the query that you're trying to implement, that, hey, what I am trying to do is basically print, let's say, names of students from student table with GPA greater than 3.0. So this is the what part of it, right? And to express that what part, you essentially use your syntax of the language, and you can write something very simple like select names from student table where GPA is greater than 3.0, right? Now, the question is, how will this be implemented? Like internally, how is the program going to interact with the student table, which is present in some database? How does it know to find the GPA? What is the logic of grabbing those information, right? So you don't have to express how it will function, right? Internally, this language knows that if something like this is written, which is essentially what the user wants from the program, right? What the user wants the program to do, it knows the mechanism or the functionalities on how to do it, right? So essentially, you don't have to express that how. However, let's say if you want to do the same thing here, but in the form of a Python program, which is not database inclusive and stuff like that, then you essentially have to write the if-else statements of finding the GPA is greater than 3, making that decision making. You have to write a loop that will go over all the different students that are present in the table. Then you have to specify that, okay, this is the print statement that I have to write and stuff like that, right? So that is basically the what part or the how part of how it will function, and that is something that you have to include when you are coding using functional languages. But however, make a note here that let's say even when you are using functional languages, right? So let's say you want to print something on the screen, right? Print something on the monitor, right? Or allow the users to specify input from the keyboard. So this is the what part of it that you write, right? So when you try to implement these type of situations in your traditional programs, right, written in Python or Java, uh, you essentially say you essentially write something like, print, that's the syntax, and then inside of this you will write something like hello world, right? Now the question is, do you specify how this print function will take this string that is written inside of this as an input parameter, and then how will it connect to the monitor of your screen, and then how will it display that particular message, right? You do not include that type of information because that is essentially already written, okay, in some inbuilt library that is available, let's say, within Python, and that same is true for the other languages as well. And that gives you some sort of a framework, quote unquote, which is going to enable you to just focus on writing the what part of your logic and then not having to worry about how it will function and having to write that code from scratch. Okay, I hope that makes sense to everybody, what I'm trying to express here, right? So essentially, now that we understand that differentiation between functional languages and non-functional languages, here, when we are trying to implement a web application, right, there are certain details that needs to be specified. Details specifically with respect to the port number on which this server will be running, how to handle HTTP requests, how to unpack that HTTP request. You see, all of these are like, quote unquote, the how part of whatever you're trying to do. Okay. So what you're trying to do, for example, in this case, is basically, as a client, you're making a request to the server. Okay. And the server, your expectation is the server should be able to receive that request, unpack that request, extract the contents within that request, and then do something after that, right? So you can write all of this from scratch by writing your own code on how the server will be hosted on a particular port number, what will be the activity, but that is a lot of code that you have to write, right? If you're writing that from scratch. So that is the reason why when implementing situations like this, we use frameworks, right? Frameworks have certain predefined code which have already expressed the logic of some of these complicated operations, right? How to unpack, how to receive the request, how to host and run the web application, how to instantiate a web application. So those codes are already written. You don't have to write that code. So all you have to do is essentially, like we have seen the examples from our previous demo, where we include an external library, right? Like bcrypt or crypto library. And then we don't write the code manually on, let's say, things like, oh, if you want to use, let's say, a SHA-256 secure hash function, right? You don't have to manually write how that code will work, because the library already has that written. So you just call the function that implements it for you. So we have similar support and capabilities when developing web applications as well, right? So the web application that we will be using, or the framework that we will be using in Python for our particular demo here, is called Flask. Okay. Flask is basically a very lightweight micro web framework, right? And the reason why we call it micro is because it is very minimalistic in nature. So that means it will only include the tools. And essentially, the tools means the methods that have the details of what we are trying to implement. So only the basic tools are included for building web applications, right? It does not provide us with a bunch of additional sub-libraries that might be used, right? So essentially, you can extend it easily. So if you need additional features, like you want to implement some sort of an authentication, or you want to implement some sort of a database integration, right? So then you can very easily extend that. But when you initially integrate it to your program, it only gives you the basic necessities that are necessary to build a very simple web application, right? So it is a very lightweight, very minimalistic. It also has a built-in development server. So that means I do not have to go out there and find external web servers. So for example, there are certain applications, certain softwares that are just meant to act as a web server. So for example, Apache is one of the examples. NGINX is one of the examples. So these are softwares, you run those softwares, you take the folder inside of which you have written your code, and you drop that folder within that particular directory, which is basically where the web application or the web server is accessing the code from, right? So you don't have to do that, because Flask comes with a built-in development server. So when you run the Flask application, and remember, this is for just development purposes. There are two different categories here. One is the development environment. When we are dealing with web applications, there is a development environment, and then there is a production environment, right? So production environment is what where we deploy it when we want to release the application that we have developed to the general public, right? And of course, as the name suggests, development environment is something for us developers when we are just building the application and we want to test it, right? So that is the development environment. So there is a little bit of flexibility in the development environment, and the production environment is a much more stricter, because you are releasing it for the general public consumption. So you have to be much more careful when you send it there. And when you send it for a production server, then we won't be using these built-in servers. We will essentially be using the separate web servers that are there, which can host our server, right? So in that situation, we will change the ideology a little bit, and then, but for in this particular case, since we are only just testing our SQLi demo, a development server is good enough. We don't have to worry about production environments. And then for such a situation, having a built-in development server that comes with our web application framework like Flask is going to be very helpful for the developer experience, right? So Flask is essentially very good for quick prototypes. So in this case, we are just trying to develop a very minimalistic web application. So Flask is quite well suited for this type of use case scenario. Generally speaking, for production environments, it's pretty good for small to medium-sized web applications as well. So you can use it for production environments. It's pretty good with API integrations and backend services, right? So that is a pretty nice choice to have when you are developing this. It is easy to use, as I discussed. It is very lightweight and modular. It has only the essential tools, and then you can add any additional functionalities that you need. You can extend it very easily. You can customize it based on your requirement. And at the end of the day, it has a good community support as well. So if you're stuck, if you get into any kind of errors, then you can check out the community support and see if somebody else has faced that problem, and they can help you out if you make a post and stuff like that, right? Some of the key components of Flask that we need to be familiar with, and these all relates back to the overview that I discussed. What are the different functionalities and the interactions that are happening? That is essentially what these key components are implementing, right? So we have some components for routing. So routing essentially means that, okay, if the user interacts with the front end and makes certain interactions with one of the functionalities that you have implemented, so let's say a login functionality, then how do we send that information to the application server, and how does the server know that which function to execute? As I said, that in the application server side, we can write functions that will be executed depending on the nature of the request that we are receiving from the user. So that means if the user wants to create an account, there will be a separate function for it in the application server. If the user wants to log in, there could be a separate functionality. If the user wants to see a list of items that are on sale right now, that is a separate functionality, right? So then the basic question is that whenever any type of HTTP request is received by the server, the backend server, then how does the server know which function should be executed by looking at the user request or the HTTP request that has been received by that particular server? So that is something which is implemented by what we call as the app.route, where app is basically terminology that is used to represent our application server, right? That is where the app is coming from. So using what we call as decorators, and I will talk a little bit about what decorators are so that it makes sense. But for now, just understand that this is a terminology that we use whenever you see a line of code which begins with @ and then something is there right after that in Python, and some other languages have it too. Then we call that as decorators, right? And for routing purposes, this is what we call as routing, okay? It is to basically give our backend application server the ability to understand the user requests that are incoming from the front end and to route it, that is to direct it or channel it to the appropriate functions that will be able to handle that request. Okay. Now, that brings us to the very next operation, which is how do you handle the request? That is, when an HTTP request is received, how does the application server unpacks that and understands that, oh, I need to use this particular route. This is a login request, or this is a account creation request, or this is a items on sale request, right? How does it understand that? So that is handled by a process that we call as request handling. And there are request methods that are present within Flask that helps us implement those operations. The next thing are templates. Now, for templates, you would have to essentially have an understanding of HTML a little bit, okay? And I know that's a lot to digest right now, but let's see if we can at least have a overview of the understanding of what templates is and why templates are required when we are trying to build web applications. So the language that web browsers understand, okay, so I will just specify the keywords here. The language that web browsers essentially understand is HTML, CSS, and JavaScript. Okay, so these are the three main languages that is understood by the web browser, by any web browser, and it is able to basically look at what you are trying to write in your code using HTML. So HTML is basically used for what we call as content structuring. We'll come back to these terminologies in a short while. CSS is for styling, okay, and JavaScript is for dynamic functionality, right? Dynamic content generation. It can also support user interaction, like mouse clicks or scrolling behavior that you do on the web pages, or it can also do like keyboard inputs. So it can track all of these different types of interactions from the user on the web browser itself, right? So what we mean by content structuring is that, let's say you want to specify some sort of an information which looks something like this. So we want to say, hello, welcome to my web application, right? So this is a general message that you want to display. And let's say then you want to display a dynamic message. So let's say this is a message that you want to show before login. And after login, you want to say, hello, John, welcome to my web application, right? And this is after login. You want to display this message on your web browser, right? Through your web application. And please note that this part here, okay, so let's see, I need to find okay, this is bad. Let's do this. All right. So this highlighted one is basically a dynamic message, right? And what I mean by that, essentially, depending on who has logged in, this particular string value will change. So that is why we are saying this is dynamic. All right. Now, what HTML stands for is hypertext markup language. So it is basically a markup language which is understood by the browser. So when the browser sees it, it can display it as a regular text depending on the tags that you're using. So that means HTML is essentially expressed with the help of these hypertext markup language tags. So for example, if you want to display a main heading on your browser, then you would write something along the lines of the H1 tag, which is representing the highest level of heading on a web page. And you can say, you can use the same message and you can put it here, and then you have to close the tag after that. So this is a closing tag, okay? And then when the web browser sees this particular line of code, okay, then the web browser knows by looking at the tag first, it knows the meaning that you as a developer, you're trying to represent. So this is known as heading, okay? And then it will take the content that is wrapped inside these HTML tags, and it will essentially render that out. Similarly, let's say if you want to take a text input from the user, all right? So the HTML tag, which the browser essentially understands to take input from the user, is called input. And then HTML has certain what we call as HTML attributes that provides supplementary information to the main HTML tag. So that means if I say that the input type is going to be text, then when the browser renders this information or this tag, then it expects textual input in this input field from the user. And there are other attributes as well. I will discuss that when we implement this. And then we close the tag. Now, this tag is a self-closing tag. You can see here, if you compare it from this particular tag, which has a start tag and an end tag, this input tag in particular does not have an end tag like this H1 tag. right? So we call these as a self-closing tag. So it closes by itself. Where it starts, it ends within that tag itself, right? So what you have to pay attention to is not specifically the syntax itself, but since this is not a proper programming language, there is no concept of variables in HTML, right? So that means in Python, in our previous programs where you have seen that you want to, let's say, write a print message, let's say. So we take a detour a little bit to the Python. Let's say you want to print something and you want to print this particular message here, right? Now, you know for a fact that this particular guy here is going to be a dynamic input. So that means, let's say we store whatever the value that will be displayed here inside a variable, and we assign that value by doing some sort of a process, right? So that means if we call this variable, regardless of whatever value is present inside this variable, when we run this print statement, we can simply replace this as like this, and then we can say $variable, right? So during the execution of this print statement, it will see that there is a reference to a variable. So it will replace the variable with whatever content is actually present within that variable name, right? So that means that if after login, the content is John that is assigned to the variable, it will display hello, John. If it is Jane, it will display hello, Jane. Now, the problem is the typical HTML, the standard HTML does not have these type of functionality present. So that means we cannot embed dynamic data inside of traditional HTML. So let me write that down to make more sense. We cannot embed dynamic data inside HTML. HTML does not have that sort of a functionality or does not support such type of functionalities. But however, when we are developing web applications, right, we might be in a position where depending on the type of interaction that you have taken place, so which in this case is, let's say after the login, you want to give a more custom or user-tailored welcome message rather than giving a generic welcome message, right? So for that, you need to know who has logged in to your application, right? And then you have to change this name. But you cannot do that here because you cannot write something like dollar and name. This is not supported by HTML. So in order to overcome that challenge, sometimes people use JavaScript and other technologies, depending on the type of technology that you're using to build your web application, have their own functionalities, right? So the support that is there for Python-based web application development is in the form of HTML templates, right? So these HTML templates essentially are a HTML-like code. So it will have all the HTML tags that we generally use when we are writing HTML, right? But in addition to that, it can also support these type of dynamic operations, which we are more familiar with in the traditional programming language. So then when the server renders that HTML template, it understands that, oh, you're trying to use the value which is present inside this variable. So let me just replace that and then send that HTML page to the user. So when the user sees it, they will see this message essentially. Okay, they will understand this, and then the browser can essentially render that message. Okay, so that is the idea behind templates. Okay, so templates are necessary for us to be able to allow our servers to generate dynamic content within your HTML file. Okay, because HTML by itself cannot support any dynamic content. It doesn't have any concept of variables. It doesn't have any concept of if-else statements. It doesn't have any concept of implementing loops. It doesn't have any of those things, right? It's basically a markup language. Okay, so we do not term HTML as a programming language because there are certain features that needs to be supported by a programming language so that we can call it a programming language, okay, which is not present in HTML. Okay, so that is the reason why we need templates. Okay, and I hope that makes sense with respect to what templates are and why we are using it in this particular context. The other thing that we need is to preserve context, and context is preserved by using certain special objects within Flask that is known as the G object and the app context object for sharing data across requests. Okay, and what this means is that, let's say, if you have a particular request that will generate some data which needs to be accessed across multiple functions within your backend server, right? So that means a login functionality, some data will be generated for login with respect to who is logging in, was the authentication successful, let's say what type of authorization they have. And then you need to pass that or share that information with another function, which would be capable of showing, let's say, the wish list of the user. So in order to show the wish list of the user or the saved items that the user wants to buy, you need to know what the user is, right? Or who the user is, essentially, right? And that information comes from a separate function, which is the login function. So now there is a requirement here where, given a particular request, you have to share your data across multiple functions, right? So that is essentially enabled by these special objects, such what we call as G and app context within Flask, right? So that preserves context. And then we have middleware operations. So middleware operations are basically certain operations which further helps with processing the requests or further helps with processing the data before we send it back to the user, right? So that means if we go back to our original example, let's say once the response is received from the database server to the application server, and then some processing takes place within the application server, before we send it to the front end, if there is certain pre-processing that is required to make it look presentable for the user, then we implement those functionalities as middleware. So think of the middleware like this software stack that is on the same system as that of the web server or the application server, right? It could be on the application server. If you have a separation between the web server and the application server, it could be present on the web server, it could be present on the application server, depending on the logic, right? And these middleware functions, I will just write here MDware to make sense. And it can receive the requests. And when it receives the request, it can do certain pre-processing before routing that request to the actual function which will do the proper processing, right? Which could be in the form of, let's say, sanitizing the inputs, making sure that no wrong inputs are given and stuff like that. This is just a simple example, right? This is not exactly the use case scenario. Similarly, before you send it back to the user, it can pass through the middleware server. And then the middleware server, you can write additional functionalities, which can, let's say, implement certain additional logic on top of your code. For example, making the response more presentable, processing it, which we can call as post-processing, okay? And then it can be sent. So if you think about, processing data, you can break it down into three different segments, right? So you can have the actual processing, which will be done by the functions that is written on the application server. But before processing, you can have some sort of a pre-processing, and after the processing, you can have some sort of post-processing, right? So pre-processing and post-processing are not necessarily a part of your actual functionality, but nonetheless could be very important in facilitating better or seamless operationality of your entire web application, right? So these pre-processing part and these post-processing part can be implemented by what we call as middleware functions. That makes our life easier, right? So that is what middleware functions are. And what is important is that the Flask framework comes with a lot of inbuilt hooks are basically another way of saying a function, okay? And that is an oversimplification, the explanation. But for us to understand at a very beginner level, you can think of hooks like functionalities, which can be called as a function, okay? So you can essentially get help from all of the logic that is written within those middleware functions. You don't have to write the entirety of the function by yourself. There are many inbuilt functions which are available. So for example, this is one example. And what this is saying is that there is a middleware function, so that is instantiated by our application, denoted by app. And this runs before the requests are processed, right? So that means this will be some sort of a pre-processing operation before it is sent to the actual processing, right? So that is basically the benefits of having middleware functionalities, right? So these are some of the important key components that will be helping us in order to develop this operation, okay? And then after that, just to give you a quick overview that there are alternatives to Flask as well. And I'm only discussing Python-based technologies. I'm not discussing, other stuff. There are many other ways to implement web applications. You have the trusty old JavaScript, you have PHP, you have Rust, you have Ruby on Rails, you have Java server pages, but I don't think anybody uses JSP anymore. But yeah, essentially what it means is like there are many, many different technologies out there that you can use to implement web applications, right? So I'm just talking about the alternatives to Flask in Python. So the popular one will be Django. Django is not a minimalist framework like Flask. It is like the complete package. So it will give you an interface for administrative purposes. It will give you inbuilt authentication capabilities. And it is very well suited for larger and more complex applications, right? So if you're developing like a very large scale application, which requires all possible functionalities for web applications, then Django is the way to go about it, right? There are other smaller frameworks, lightweight frameworks, just like Flask. So you have Fast API, you have Pyramid, and then you have Bottle, which is more recent, which is more minimalistic than Flask itself, right? And that is something you can see. We developers are very good with naming conventions. So if you actually think in terms of the literal meaning of Flask versus a bottle, you will get an idea of what it's trying to convey, right? So you can check these things out. This is just to inform you that these are options that are available alternatively to Flask. So if you're ever in a situation, just to be aware of it. All right. So moving on to the prerequisites for our program itself, we will need to install two specific imports. One is Flask itself, and we know we need Flask for our web development purposes. And then we need SQLite, which is going to be simulating our database development server. It will emulate it, right? Because it's not a real database server. Please remember that. Don't treat it as one. It's file-based, okay? But it emulates SQL. So it supports SQL. So we can query it as if it was a real relational database which runs SQL. So it's very good for quick prototyping. If you want to test out your database environment for small projects, see what the schema and the structure should be like, and then try out different queries, then it's a very good place to start, right? Then you can migrate all of that into a proper database environment. And since it supports SQL, you can migrate all the SQL schemas, and then you can import those schemas using SQL again to the real database environment. So you don't have to write everything from scratch if you prototype it using SQLite, right? In Flask, we will be importing the class for Flask itself, which will be implementing all of the different core functionalities that we will need to build our web application. So that means how to initialize and run our web server, how to manage the different HTTP routes, and receiving the request. We will have the request handler. So that is basically an object that will be able to understand the incoming HTTP request from the client. So HTTP requests can be in two main formats. There could be more different variations for this, but the primarily used HTTP requests are in the form of post, okay, and then get. So get request, essentially the user is requesting some data back from the server, and post request is essentially when the user is essentially giving some information there, right? Reading data. So actually, no. So get request, whatever input is provided by the user from the front end side, that input is essentially embedded in the URL itself. And then the post request, you would have that embedded inside a web form. So you have to unpack the web form and then extract the information from there, right? And for the get request, you will essentially have to extract the information from the URL parameters itself, which is being received from the HTTP request. Okay. So those are the two types of requests. So the request object can basically understand that and unpack that HTTP request and then see it. We also need the render template from the Flask import, which is to dynamically generate our HTML content. We already discussed this, why it is necessary. And then we need the special object that is represented by G, which essentially allows us that given a particular request context, it will allow us to essentially share the data throughout our functionalities within our web application, so that we don't have to establish different connections for different functions with our database, right? So those are some of the prerequisites that we will be implementing in order to get things started. Security logic, we have already discussed this, so I'm not going to go into too much detail about how SQL attacks, SQL injection attacks work, what is the logic behind it. You can recall the lectures that we have already done on this, or you can check it out on the web. But the focus of our application, would be in the form of looking at the fact that the vulnerability of SQLI attacks that happens if, as programmers, we do not separate the query from data, right? So if you look at a typical SQL query, it will be in this select from where format, where you can select everything from, let's say, a table that is called users, and then where the conditions is the username, and then some data will be provided by the user, and then we have the logical AND operator, and then you will check the password by comparing it against the information that is provided by the users here, right? So that is essentially what we can check with, okay? So this is where the issue arises, because what happens is that if you do not have the separation between the data and the query itself, and you implement it in the form of, let's say, a string in Python like this, okay? So what happens here is that this will be replaced by the user data. This will be replaced by the user data. And since we are concatenating everything in the form of a simple string, if the user provides certain input, which is a malicious code, then that will become a part of the SQL query itself. And then we can, manipulate the original SQL query to something else that the adversary injects through the input fields of the front end, right? And that will create some problems, right? So again, you can recall the discussions, the examples that we have discussed on what type of inputs that can be given here, which will result in the malicious queries. Essentially, you can inject that here. And if you are writing that as a string with no separation of your query from your data, then you are in big trouble, right? So our focus is here. This is the vulnerability that we will implement, right? And the way we want to resolve this is we want to implement the query that will be run against our database in the form of a parameterized query, all right? And the idea behind parameterized query is that we want to separate the data entity from the query entity of an SQL query, all right? So that means here, if we write the query like this, not as a string, okay, but as a parameterized query. So we call this a parameterized query because you can see here, these characters will be replaced during runtime with the input data that is provided by the user from the front-end form fields, all right? So that means whatever is replacing this character here during runtime, that is treated solely as a data, and there is no confusion with respect to whether that input is a part of the query or not, because you have already separated that. This is what the query is. Nothing other than this will be treated as the query. So if a user tries to inject some sort of malicious SQL codes here, that will still be treated as a part of the data, and it will be whenever you go to the database, you will check for it. You will either not find it, or it will create some sort of an error if you have some weird symbols and stuff like that. So that will essentially, address the vulnerability and prohibit the chance of an SQL injection attack on your database, right? So that is basically the idea behind the SQL injection attack. And I know I didn't discuss the actual logic of it that will make this video way too big. So again, watch the recordings from the lecture or look it up on Google. What is SQLI attacks? What are the example test cases of how it happens, right? So let us now move ahead and switch into our implementation and then start working on that, okay? All right. So we have switched on to our Visual Studio Code editor. What I have done is I have created a new directory here called SQLI Attack Demo. And inside of that, I have created a Python file and have titled that Python file as app.py, which is typically the naming convention that we use when we are building a web application in Python, right? So essentially, we call the main file within our web server as app.py. So this is going to be the main file here. So that is the naming convention that we are using. Now, as promised, as I did say, I'm going to talk a little bit about decorators first. Okay, so we will discuss a little bit about decorators so that we understand what it is. And then when we are implementing the actual web application, it will make a little bit more sense to understand what it does. All right. So the logic of the decorator, what a decorator does is a decorator is basically a function by itself. And what it does is it wraps around a separate function. Okay. So what happens since you wrap it, it's kind of like a wrapper. So when you execute, let's call this function 1. And let's call this function 2. So when you execute function 2, then essentially function 1 can execute before or after, depending on how you call it, the function 2, since it is essentially a wrapper, right? So it's like, let's say you want to access a candy, right? Your candy in this particular example is function 2, and then a candy has a wrapper, which let's say is function 1. So essentially, when you're trying to access your candy, you first have to go through your wrapper, right? So this does not change the nature of the candy, right? But it allows us to access the idea of the wrapper. We can implement certain functionalities within that, right? So let's write function 2 first. So let's say we want to write function 2 here. Let's say we want a very simple logic. We define a function, let's say print hello. Okay, so let's say we want to write this function and we have a function body, which is simply going to print a hello message. All right, so we will just say hello, something like this. And we call this function. So we will just write the name of the function. So we will say print hello, right? So if we run this particular function now, so I go here and I do Python print, not print, but app.py. So we get the message hello there, right? So all good. Now, what if before this function executes, right, I want to implement some additional functionality that will be connected to the execution of this function. So what I mean this is, let's say I want to print some more statements, but I don't want to include those additional statements within this function because the primary purpose of this function is to print just a hello message. But for pre-processing purposes, when this function gets executed, okay, I want to implement a wrapper around this function such that by default, whenever this function gets called, then the functionality that is present within that wrapper function that wraps this particular function gets executed as well. All right. So I know I used a lot of function terms in that, but let's implement this and hopefully it will make more sense. So let's say I implement a new function. I call it my decorator. So this is basically for the Python decorator itself, right? And this is going to take as input a function parameter. And how I'm going to implement this is by defining it as a wrapper, which is an internal keyword there, right? So I will implement it as a wrapper. And then the functionality of the wrapper is, let's say, print some additional messages. So I will say something is happening before the function is called. All right. And then after that, I call the function itself. And by the way, this function is going to be this wrapper, the wrapper around this function, because this is wrapping this particular function. So this func that you see here as an input parameter, this is what the wrapped function would be. Okay. And then after that, so this is going to be a function call because it wraps around another function. And then I can say something like print. And then I can say something is happening after the function is called. And what is the function? The function is basically going to be any function which is being wrapped by this decorator. All right. So you can see here the logic of these functions includes additional print statements that will be executed before and after the actual function call. But these print statements on line 7 and line 9 are not a part of the actual functionality of the print hello function. The print hello function's functionality is just to print hello. But what if I want to print line 7 and line 9 only when this print hello function is called without including the logic on line 7 and line 9 inside the actual body of the print hello function? That is the problem that we're trying to solve here. Again, I will repeat this. I have an actual function which has a specific functionality. However, I also have a requirement that when this function gets called, I want to execute some additional functionality either before or after the function gets called. And I don't want to include that functionality, those additional functionalities within the main body of the function because that is not a part of that function. So what I do is I create a wrapper around that function, which is represented as a decorator. All right. So I declare my decorator. I pass as input the function which will be wrapped around by this decorator, and I define it as a wrapper. And then I provide the additional functionalities that I would want to execute when the original function gets called, either before or after, depending on my logic, right? And what is this final decorator going to return? This final decorator is essentially going to return the wrapper itself that we have defined. Okay. All right. So now what I can do is once I have declared my wrapper and my decorator, I will take my decorator, which is basically this function name, and I will put it here right before the execution of, or I will wrap it. So I can say that this essentially wraps the print hello function. Okay, so hopefully that makes sense. So now if I execute this method or execute this, you can see here, since this decorator, we call this a decorator, and decorator is nothing but a function that is defined as a wrapper around a particular function which is provided as input to the decorator. All right. So this print hello function gets called, but it is wrapped by this decorator. So it takes this print hello function, passes it as an input to this my decorator function, which is defined as a wrapper. And the wrapper has its own logic. And there is a logic that is executed before the function call, and there is a logic that is executed after the function call. You can choose to do either or both, depending on whatever your wrapper logic is, right? And then that wrapper logic gets printed here, right? So this is what the whole idea behind decorators are. So now in our web application implementation, in Flask library, we have certain inbuilt decorators. So then what are decorators? Decorators are nothing but another function which is defined as a wrapper around the function that you pass as an input to the decorator, which is basically written right before the definition of the actual function which you're trying to wrap using the decorator. So there are many different decorators. And when I say many different decorators, that means there are different logic that is implemented by different decorators. Okay. So that is what the whole idea or the reason behind using decorators are. And we are going to be using certain decorators inside our web application development such that we can harness the pre-processing or post-processing capabilities around our actual function that we will implement without having to modify the main code of our original function. So this is basically going to act as a wrapper. So that's the idea behind decorators itself. So hope everybody understands what we are trying to do here. Okay. So I will remove the terminal for a second because we won't need that. Actually, we will need that right now. So the first thing that we need to do here is we need to install our libraries or our dependencies, right? So our dependencies is going to be Flask, okay, Flask, and then we also need to install SQLite, okay? So SQLite version 3. So we will install these two things. So we will first write pip install Flask. Okay, make sure that we are in the correct directory. We are not inside any other random subdirectory and everything looks good. And we will run this. Okay, it's taking a while. All right. Okay, so we have an error here. So we will address this error and we will see what this error is, but I just want to run through the other installation. And if there is error with that, we can address both of the errors together, or otherwise I will just focus on the first error and see what has gone wrong there. So we will just do pip install and then we will say SQLite. I hope that SQLite is an inbuilt, but let's see. Okay, so no matching distribution found for SQLite, and we will just check it here, right? So the way I want to check it is I'll just write the import statements for these two, and we will say from Flask, import, and we need the library for Flask itself. We need the request object, then we need the render template, and then we need not the render template, but we need the render template string specifically, and then we need the G object. And then we also need the import SQL Lite 3. Okay, so SQLite is inbuilt itself, so we don't have to import it separately. This is the reason why I ran this statement first, because from the previous demo, if you remember, we had one of the libraries which we tried installing, but now given the updated versions of Python, it already is present there. So SQLite 3 is already present. So then we will essentially have to resolve the error for Flask itself. So I will pause the recording, check what the error, this particular error message is, and hopefully we can solve this quickly. So give me a moment. Let me pause the recording, and I will get back to you in hopefully a short while. Okay, so we got one indication of what could be happening is that what this error message refers to is that it's trying to execute an operation which requires some sort of a special privilege, essentially. So we don't have that special privilege. So what I'm trying to, or what I will try to do is I will try to install Flask without any special admin privileges. If that doesn't work out, then I will have to probably open a new command prompt and execute that as an administrator and then try installing Flask again, right? So we will try first to install Flask without any special privileges. So I will clear this up a little bit, okay? And then we will say pip install package name. So package name is Flask. and then I want to install this as a regular user, and I do not want to install this as an administrator. So let's see if this works out. Everything is already satisfied. So the installation went successful, but it seems that the, what do you call it? That final file, that delete me file, I think that was right here somewhere, right? Let's see, requirement already satisfied, requirement already satisfied. Where was that error code? Okay, that error code got removed completely. That's not good. And then if we try to install this without normal user privilege, let's see if we can still hit that. No, everything just went smooth. Okay, so let's just refresh this, put it out, and let's see if it still creates problem or not. Okay, we'll go ahead and start implementing it and see if it gives us a problem or not. If it doesn't give us a problem, then hopefully it has identified it. Or if it is still cannot import it, then we will know that we still have to fix whatever problem that we faced, right? Which is a problem because now the installation says that it is already satisfied, but we have to figure that out. It's okay. We will figure it out as we move forward with it, all right? Essentially, what we can try doing is we remove this and we try it again. So we will say Flask. Here we go. No. Okay. So we don't want to import Flask itself. So we want to say from Flask, and I can see Flask core here. And I can see some of the Flask sub-libraries are there, but I don't see the full library by itself. Okay, you'll see. So maybe we can try, let's say this one, and that is not the correct thing. That is, I'm sure of. So we'll just implode it and see what happens. I think we still need to fix these errors. And yeah, I was already prepared. All these things are going to happen. So it's all right. We'll deal with it. Okay, so we'll take care of it. So the first thing is we will have to do the same thing. We need to write down the roadmap for our implementation. So we will remove the terminal for a second because we don't need it for the time being. So let's see. What do we need to do here? First step, we need to initialize an instance of our Flask web application. So that is going to be the first step. Then what do we need to do is declare a database name that we are going to be using. Cool. Then what we want to do is we need to establish connection with our database. So remember, right now in SQLite, this is not a connection with a separate server, but this will be like very similar to a connection that we established with a file. So remember in the previous demos, we had established a connection with some of the files that we were working with in the digital signature verification, the password storage, right? And then we used to do the with open, and then we provided the file name, and then we created an instantiation of our file reader. So that is what this established connection means, that it will establish a connection with the SQLite DB file, okay? So once we establish that connection, we also need to make sure that we close the DB connection right after that, all right? And then once we close the connection, we need to essentially initialize the DB, right, database. So here we will insert our mock data. Okay. All right. So we will initialize and insert our mock data within this function. So we will write this as a function. So let's just write down the functions that we need. So we will write this as a function. We will write this as a function. We will write this as a function. All right. We don't need a function for this. We don't need a function for this. This will be lines of code. And after this, we will have our web server routes, right? So these are basically the type of functionalities that will be supported by our web server itself. So that means we will have a web server for the home page. Okay, so we will write this as a function again. All right, and then after this, we will have another functionality, which will be for the login function, right? So this will be implemented as a function itself. And in this, I think we will query the database. All right, there we go. I don't know if you guys noticed it in real time. You can pull back the video, but essentially after that refresh, VS Code essentially found this, right? So you can see here that squiggly underline just went away. So there we go, debugging 101. That gives me a good relief, right? Because on the other side, in some other corner of my brain, I was thinking like, what else am I going to do in order to resolve that? Because I was quite leaning towards having to remove what it says that requirements are satisfied. So sometimes what happens is that if it says satisfied, what you can do is you can try restarting your Visual Studio Code editor. That will refresh it, or give it some time, and that will, when it does, save it, and then it will essentially find that. So yeah, I mean, honestly, in debugging, there is a lot of time you do things right, and then you don't know why it doesn't work, and then again, you don't know why it does work. Yeah. So anyways, hopefully you guys don't face some problem that you are stuck with, and it should be smooth. So one thing to note here is, make a quick note when you do install it, please run using this command so that it doesn't require you to run it with admin privileges. So hopefully that will just bypass the error that was given, and you should be good to go with respect to the installations. Okay. All right. Okay, so where were we? So we wanted a login functionalities, and this is where we want to query the database. So here we will have the essentially the vulnerability for SQLI attacks. We'll put it here. All right. And then after this, we will need a main function. The main function, the whole purpose of the main function is going to be run the database initialization function. So that is going to be step 5. Okay. And then after that, we will run the web application. Right. So we need a specific line of code for that. And that should be it, I think. All right. Okay. I think that should be it. And anything else that props up while we work on this, we can just add it as we go forward with it. All right. So let's see. First is we need to initialize an instance of the Flask web application, right? So remember, we have imported Flask, and then we have this core Flask class. So we want to make an instance of this class, right? So this is coming from object-oriented programming. So we are going to call our instance of our web application as app. That is the reason why we have named it as app.py. And this is going to call on Flask itself, and to it as an input, we will pass the name that is creating this instantiation. So in this case, it will be app itself, right? So that is basically the initialization of our Flask web application. So I will copy this guy here, bring it here, create a comment, indentation, right? And then put it here. Next thing, what is step 2? We need to declare our database. So we will copy this, we'll create a comment here, put it here, and then here we can give a name of our database. We will call it database itself, okay? And then we will give it a name. So let's say if we are storing users information, so we will call it users.db. So the extension for SQLite are stored in files which have an extension of .db, right? It's not .txt or .xl or anything like that. It has its own specific file type. And that file type is .db. But remember, again, this is not a real database server. It's a file-based database. which can support structured query language. This is a very important distinction you should remember. Okay, so essentially what we are doing is we are giving a name to our database file and we are assigning that to this particular variable here. All right. So next, we need to essentially create an instance of our database itself. So that means what we want to do, the logic that we want to implement is create the database with name in the line above. So we will say line of code above if it does not exist already. So that is what we want to implement. Okay. So I want to create a function, and let's say we call this function as get database. So we are essentially grabbing the database by creating it if it doesn't exist. So we will also say we will establish a connection with the database after creating it. All right. So we will define it as a function. The function does not require any input parameters to it. We will declare the instance of a database and we'll assign it to an object. We will call it DB itself. And we will call this get attribute function. Okay. So this is going to basically just return the attribute it doesn't exist by creating it. So that means if this name of the database that we are trying to create, if it doesn't exist, then instead of giving an error when we are trying to establish connection with it, it essentially creates that database first and then establishes the connection, right? So that is why we are using this particular function. And to it, we are going to pass our special database object, which allows us to share context across different variables. And then we are going to give it a name of underscore database. Okay. And then the last attribute, we're just simply going to say that there is no particular default value there. We will put it there. And then we will run an if-else statement, which will say if the database doesn't exist. So we are going to say if database is none, right? Then what do you want to do? We want to create that database and connect to it. So we will say database is equals to g dot underscore database. Okay. And this will be assigned to a connectivity using SQLite 3 with the connect method that establishes connection to the database. And what is the name of the database? We have declared that in our previous lines of code here. So this is going to establish that connection. And once that connection is established, we'll get outside of this if statement and we will return the database that has been created. All right. So that is basically with respect to creating the connection. So if we have created a connection, we also need to close the connection when our operations is done against the database. So we're going to go ahead and move on to the next function. We will say close the connection when the operations against the database has been completed. Okay. So this will be defined as a function itself. We will say define close connection. That is what the purpose of this function is going to be. And then if there are any errors when we are trying to close the connection, then that will be captured within a parameter and we are going to call that parameter as exception. And then what this is going to do is first, this will again establish the connection with the database. So that means DB is going to be this same line of code, right? So I'll copy paste that line of code there. And then we are going to run an if-else statement and we will say if DB is not none. Okay, so that means something is present within the database. Then we are going to essentially call the close parameter or the close method, which is an internal method within SQLite, and that will close. However, there is a post-processing operation that needs to be executed. Okay, so that means after the request has been executed, which will require the database itself, okay, we want to make sure that this connection that has been created is properly released. So that means all of the resources that was allocated in order to connect to the database has been released. But if you notice here in the actual functionality, I have only written the code to close the connection. I have not verified anything for my exception. I have not verified that all the resources that supports this connectivity has been properly released after this connection has been closed. So instead of writing that from scratch, what I'm going to make use of is basically a Python decorator. And that Python decorator is associated to our application itself. And the specific decorator that we want to use is called tear down app context. Okay, and tear down app context will wrap this close connection by ensuring that all the resources that has been allocated when a database connection was established will be released properly, raising exceptions if it happens when the connection is essentially closed by our close connection function. Okay, so that is basically all that we need in terms of our decorator. So this is the reason why decorators are pretty useful, because I don't have to write how to release those resources and stuff like that. Okay. Anyways. All right. So moving on. So now we have created our database. If it doesn't exist, established a connection, created a function that will close the connection when our operations are done by also wrapping it with the tear down app context Python decorator. So next, what is the next step? Okay, so we need to initialize the DB, and then within this, we need to insert some mock data, which will fill the database itself, right? So we need to initialize init the DB and insert some mock data. All right, how do we do this? All right, so let's say we do def, and then we need to write it as a function. So we will do init underscore DB, which essentially stands for initialize database. Write this as a function, and then we are going to use another decorator here, but we are not going to be writing it as a decorator itself. We are going to say with app underscore context. Here we go. Okay, so we'll open the application context of our web server, grab the database to which a connection has been established. So that is going to be this function, because this function establishes that connection, creates that database. So we call that function, it does all of this, and you can see here this function returns the database itself that has been created. So we are storing that here. So we're bringing it out of this function and we are dumping it inside this function so we can actually insert the data. Now, what we need here is something that we call as a cursor object in Python. So what this essentially implements is, let's say we need an object relation mapping. So what does this mean? Databases understand SQL, okay? But I'm writing this code here in Python. So that means I need some sort of a connector of Python and database that will enable me to write SQL queries in Python itself and not SQL. So it will look like SQL, but the code itself will be in Python. But there will be a connector such that when this code actually executes, the server understands that this is a query against the database, and it will transform that object, which is this guy, to the relational mapping that will be understood by the database itself. So essentially, what this boils down to is a cursor is an object, okay, which is used to execute SQL queries and fetch results from the database, from the, let me put it this way, relational database. Okay. So all I'm doing here is I'm writing SQL in Python. Okay. And this object can essentially translate that Python code to SQL and then run it against the database and then grab the data from it, right? So that object is called a cursor object, and it's a part of the object relational mapping, okay? The ORM model that is there, all right? So I'm going to create a new instance of this cursor object. So that has to be associated with the database against which I'm going to run the SQL query. So I'm going to use DB, which is my database here in line 34, and I'm going to generate a cursor object by calling the default constructor. Okay. And once this is done, now I can write the code for my table. Remember, I have only created a database up until this point. Now I need to create a table, and then inside the table, I need to insert the data. So I'm going to say here, create table inside my, not by, inside my database. So the syntax for that is I use the cursor object that I declared in line 45. Okay. And it has a method called execute that allows us to execute the SQL queries, right? So that is a method. So it will take an input parameter, and the input parameter will be the SQL query that I want to execute, right? So I can write inside of this as SQL, but Python will be able to understand that because of this cursor object, right? And then map it to the proper SQL query that I really want to create, right? So what I can write here to create a table is create table, and I have to use this syntax saying if not exists, right? So these are SQL syntax, and the table name is going to be users, same name as the database, and it will have the following columns. Okay, so it will have a username column whose data type will be text, and it will have a password column whose data type will also be text. All right, I'm not worrying about primary key, foreign key. I don't have any other tables. We don't need all those operations. But it would be nice in realistic implementations for you to have primary keys at the very least. Okay, assuming that doesn't interact with other tables. And then I need to add mock data into these tables. All right. So again, we have to use cursor.execute. And then inside of that, I have to write my SQL query. So in order to insert data, the syntax in SQL is insert into table name, which is users. Okay. And then I'm going to specify the column names. So it is username, comma, password, and then I have to say values. So this is again a part of the syntax. And then let's say we want to insert a mock data, right? So for simplicity purposes, I'm not doing hash storage of our passwords and stuff like that. I'm just storing it as plain text, but never do this. A disclaimer, this is just for demo purposes only. All right, so I will separate it by a comma, and I will say something like password 1, 2, 3, something like this. So this will be our first insertion. Let us do 2 more. So I'll paste this 2 more times, and I will replace the content here. So Alice, and so let's say Bob, and then we can say something like I think I made a mistake here. Yeah. So this will be like this. Okay. And this will be like this and this. All right. So this will be secure as, I don't know, something that makes sense. Simple. And let's say we give some more password here. We can say my password. All right. And you can give some other username here. A, B, C, Alice, Bob, Charlie. Okay. All right. So looks good. Hopefully I have not made any kind of typos anywhere. Yeah, hopefully everything looks good. I don't see anything. And once this is done, in order to push the data permanently into the database, that's the final step we need to do. We need to call the command called commit, db.commit. Okay, so this will commit to the memory. So that takes care of our initialization. So let's see what else do we have. So this is done, this is done. So now we have to work on our actual web server itself. Okay, so the first thing, we have to create a home page, a route for it. We call those routes. Essentially, we don't call them functions, but it is implemented as functions at the end of the day. And we need to create a login route which will query the database. And this is where I need to present the vulnerability. Okay, so a few more steps to go. And then we can start debugging if we face any errors like we did initially. So here we will say start creating the web server routes. Okay, remember, routes are basically functions which will be fired or executed depending on the type of user request that is received by the server. So that means if the user request is for, let's say, creating an account, then I should have a route, aka function, that will be executed to facilitate that function. If login, then I need to route it to the function that can take care of login. If it's a home page, similarly a home page, and any other functions that you have. So for every functionality that you will build in your web application, you will essentially create a route for it so that it can handle that processing, right? So that is basically the idea behind it. And how does the web server know which function is associated to the HTTP request that has the user request? Well, for that, we are going to be using our Python decorators again, which will declare that if the URL is, let's write it down so it makes sense. So what I want to say is that, let's say if the URL is this is basically the URL for a home page. So I will say another comment here, and I will say URL for home page, URL route for home page is this character /. Why? Because essentially, when you do type a particular web address, right? So let's say if you have something like www.amazon.com, right? Essentially, there is actually a / character at the very end. You don't generally see that in the URL, but it is actually present there, right? So that indicates the route itself, okay? And you don't have to specify the domain because the domain is already pre-declared. So when you remove the domain, when you remove the www protocol, when you remove the HTTPS methodology, right, communication protocol on the World Wide Web service with a domain name of amazon.com, so that is basically just what protocol you're using, what service, what is the domain, and whether it is a commercial or an education application, etc., right? But after that is where your actual application resources start, and that is indicated by this /, right? So that means if you remove all the irrelevant information with respect to your application server's request, then the URL for your homepage essentially just boils down to this singular /. So that is the reason why whenever we want to create a route to the homepage, we represent the route as a simple /, right? And everybody, I hope, remembers the purpose of the wrapper. This wrapper is going to take care of translating the HTTP request that is received and then connecting it with the function that we will be wrapping it with. And we will define that as, let's say, the home page function. So how does the web server know that if this URL is typed on the web browser, it needs to direct or route that particular request to this function? It is with the help of this decorator, because this decorator now is essentially a wrapper around this function. So whenever it sees this, we don't have to write how this functionality works because it is already written for us inside the Flask class, right? So we don't have to write the details for it. So we just specify that, hey, if you see a URL, or if you receive a URL that ends with just a / and nothing after that, then please send that to this function and execute this function, okay, whatever the body of this function is. Now, what is the body of this function? We are going to return an HTML template, okay? So we are going to return by using the render template string. So this essentially allows us render template string, render template string allows us to write HTML code as a string. That's all, right? On the higher level, that is all that this thing is doing, right? So I'm going to write this as a string. So I'm going to open a multi-line bracket. And what I'm going to do here is I'm going to open a multi-line string. Okay, so I'm going to open this guy. All right, and what I'm going to do here is write some HTML. Remember, I'm writing it using the HTML syntax, but essentially in the program, it is being represented as a string and it can be returned as a string, but when it is deployed to the web browser, it gets translated to HTML code. So let's say I want to write a heading. So I will write H1 and I will say login, and then I will close my H1. So this is a little bit of practice on how HTML works as well. And then I'm going to write a form, a web form. So the HTML syntax for creating a web form is basically form. Okay. And remember, using HTML attributes, we can provide additional or supplementary information that supports an HTML tag. So here we are going to say the method attribute that will be used to deal with this form is the post tag, right? So that means all of the values that is present in this form is wrapped inside a data packet and it won't be transmitted using the URL, the web URL itself. And then it needs another parameter that is the URL generation. That is when this thing is clicked. If I click this form, right, then what will be the new URL? All right. So that means here I will say, let me write this down and hopefully it will make a little bit more sense on what I'm trying to say here. So what this is trying to say is that when this form is clicked, then this URL will be transformed to /login, and that will become a new route, which we will write after this. Okay. So we'll keep this as this. So this is what the outcome of the form essentially is, that the outcome of the form, it will further append this login word to the end of the homepage URL, and that will create a new URL, which we can route to a different function within our program. So let me finish this and it will hopefully start making a little bit more sense. Okay. Within the form, let us first close this form because otherwise we will forget it and that will result in a syntactical error. Okay. So let's say 1, 2, 3, 4. Let's give 4 white spaces to create the indentation. Remember, everything is string right now. It doesn't really matter how many indentations you use, as long as it is indented and it looks good. So now, in order to take input from the user, the HTML tag that we need is input. And remember, input has many different types of input. So that means you can give text input, you can give email input. If you give email input, then it expects the @gmail.com or yahoo.com to be present. So it has to be a proper email. You can give date type inputs, you can give file upload inputs. So there are many different types of input, right? So the type of input that we need here is a text input, and we need to give it a label that can be recognized by the server when the information is unpacked. So that label is called, let's say, username itself. All right. Then we will give another attribute, and that will act as a placeholder. So that means before the user inserts any kind of data to it, it will give like a indication on what is the expected input that we are expecting in that particular field. So we will say, enter your username. So it's like a helpful indicative message so that the user understands what are you asking in this particular input field. And then finally, in order to make sure that the user cannot skip this field, that the user has to fill this field out in a particular web form, we give this Boolean attribute called required. Okay. So there are 2 types of attributes which are assigned to a particular value. So here we are assigning a string value to this attribute, string value to this attribute, etc. And then we have Boolean attribute. So if the Boolean attributes are written, so that means its value is 1, true. If it's not written, then its value is essentially false. Okay. So then we can close this input field. Okay. And in order to create a forced new line in HTML, we will give a break tag. So this will create a forced new line. So it's like hitting an enter, and that will take you to the next line, the new content that will be rendered. And then what we can do here is we can do another input, and this time this will be for your password. So I'm going to copy this guy here, and I will change the input type to password. Right. So here we will change the input type to password. The reason why we do this is because when the user types the password, it will not show the actual characters, but it will show those bullet points like we typically see when we are typing password. We need to change the name here. So we will call this password. And instead of saying enter your username, we will say enter your password for this particular field. And then we will create another new line here, forced new line, because we're not using CSS for styling purposes and all. So it will look very, for lack of better word, simple. And then we need a button, okay, which will be of type submit. So we are going to do another input. There are different ways in which this can be implemented. The submit button, you can use a button of type submit, or you can use an input field itself and give a type of submit, okay? And then we can give a value, and that value is going to be login. All right. Since the reason why we give a value parameter here is because this is an input field, right? So it expects some sort of an input. But since the user is not giving an input, so in line 67 and line 61, the user will type the input with their keyboard. But since this is a button, which is implemented as an input, such that it expects a value to it, we are going to pre-assign a value to that particular input field, and we are going to call it a login value, okay? And then you close this. All right. Everything looks good. One thing would make it better if we add some labels to it. So, but anyways, the placeholder will do the job for now. We just need to focus on what we need to finish in order to get our SQL injection part running, right? So then we can delete this. Okay, right. So let's double check this real quick. This is the HTML that will be shown. It will show a heading, and it will present a web form, which has a method post. Once the web form is submitted, it will update the URL, home URL, by adding a login to it. So that way we can execute a login function. And essentially, we are representing the HTML as a string. All it has is 3 input fields: type text for username, type password for password, and submit button. Well, it should be a button, but anyways, we implemented it as an input field of type submit and gave it a predefined value of login because it's an input field. User expects it expects an input, and user is not giving an input. So when they click that, it essentially takes the value of login essentially. Okay, so now we can move on to the next method, which is when this action is fired, there has to be a route for the login. So you have to say create the route for login now, /login. Okay, so from home page, we create a separate route, which is /login. So we're going to say, wow, why did it auto create a comment? Okay, so we're going to say app.route. We're going to create a new route here, and the input to that new route is going to be /login. Okay, and then it's going to receive that input. So we're going to specify the method, okay, is equals to, and then the type of method that we are using is basically a post method. So we need to specify that here. All right, so that means data is being received from the user. There is no data here, so we don't need any post method or anything like that, or a get method. And then now we can wrap the function that will handle the login. So we will call it login itself. Okay, and what this needs to do. So let's write down the steps that it needs to do. It needs to unpack the HTTP request form and grab the username and password and store it in variables. So we need that. Then we need to SQL query it. SQL query using the user inputs. And here we will inject the vulnerability for SQLi attacks. All right, so let us go ahead and work on that. Okay, so we need to first create two variables. Let's call it username. And this will be extracted by using the request object, because the request object can understand the HTTP request. It will grab the form because the data is coming from the form, and the field that has the username, we will just write the name of that field. That is the reason why we gave this name here, so that when we unwrap it, we can refer to that label and it knows that, okay, I'm referring to this particular input field, right? And then I grab the value that is, given by the user input, you with the keyboard and stuff like that, right? I need to do the same thing for my password. So I'll create a variable here. I'll use the request object, which will grab the web form, and the web form, the label of that form within that form is essentially password, correct? Password, okay? So password. So now we have unpacked the data that has been provided by the user. Now we need to formulate the query. So here we will say vulnerability. All right, let's see. So for the vulnerability, we need to not separate the data from the query. So that means we need to write the entire query as a formatted string and not like a parameterized query execution. So we are going to create a variable here to which we will assign a string value, formatted string. So this is basically the formatted string. And we're going to write the query that we want to execute. So we're going to say select everything from the users table, okay, where the username is equals to, so we'll give a space, is equals to whatever input, so we'll wrap it in single quotes, whatever input is provided or saved inside this variable called username, and the password is equals to whatever input is provided inside this variable password that we have created in lines 79 and 80. Okay. Now, since this is a formatted string, right? If I provide a string input, that is, if I have special characters and stuff like that, then essentially that will bypass the formulations of the query, and that will result in a injection attack, right? Then I need to use my cursor object to run the query. Because remember, we need a mapping. We are running everything in Python, not in SQL. So whatever SQL that we formulate, we need to run it through the cursor object so that it can essentially perform that translation, right? So we are going to create a new cursor object here. So we'll call it cursor itself. And then we will run the getDB function, which will establish the connection with the database. And from that, we will create a new instantiation of our cursor. Okay. And then we will use the new instantiation of the cursor object that we created in line 86. We will call the execute method that can translate the query. And then we will pass in the line 83 variable that we created as a formatted string, right? Once that is done, we need to get the results back. So we'll store the result inside this particular object. And then we will, in order to get the response, we will say cursor dot, let's see, fetch, okay, fetch one. Okay, so it will return one at a time and we will store it there. Now we need to check it, check if successful response or not. Okay, so here we will write an if-else statement. So that means if some value is present inside this user variable, user object in line 88, then we will return some sort of a message and we will say login successful. Okay. And if this is not the case, that is, nothing is present inside that particular object, which essentially means that no data has been returned from the database, which matches the input that has been given by this username and password, then we will return something like invalid credentials or whatever message that you want to provide it with. Okay. So that should take care of this. And that would be the end of the login function. Let's see. So we grab the login, unpack the data, formulate a query, which is in a formatted string format. So essentially, this is a vulnerability. Create a cursor object by establishing connection with the DB, execute the query, and then get the results back, store it inside an object, check the object. If it is present, something is there, login is successful. If it's not, then login is unsuccessful. So hopefully we have covered everything that we need. And what is the last step? Okay, so we need to create a main function which runs the initialization of the database, which is, I believe, the initDB. Yeah, this one. And then runs the web application itself, which will be its own line of code there, right? So here we will say main function. Okay, and what this is going to do, that if underscore underscore name underscore underscore equals main underscore underscore main underscore underscore, then what is it going to do? First, it is going to call the initDB method. So you call the database initialization. Then it will take the instantiation of our web server application, which is saved as app itself. Remember, we had created this initialization here. Okay, we have created a Flask web application, which is now referred to as app. Okay, the reason why I'm using the same name here is because it is taking the name of the file and then storing that. So that is why the file is also referred to as app.py. So here we need to run this. So running this is pretty straightforward. We are going to call a method called run. But I want to provide it with an additional parameter here to run this. And I want to run this in debug mode. So essentially what this means is that once I run the server, and if I make any changes to the code, it will automatically track those changes and restart the server without me having to manually restart the server every time I make a change to the code, right? So I don't have to touch the execution of the code anymore. Once I run it, it's going to keep a track of every change that is happening to your code. So if you change something, let's say here, or something, let's say in any of these lines, it will auto restart the server. Okay, so that is what this debug equals to true means. Okay, you should not use this when you are actually deploying this in a practical scenario. All right, so I'm hoping that I have done everything correctly, but we can figure it out. The best way to know is to run this. And what we have to do here, I must make a comment here, is that we need to run this in terminal. Then we need to open a web browser, since this is a web application. And since this server is running on our own local system and not on the internet, okay, we need to type either localhost, and the default port that is used for executing or accessing a Flask web server is 5000. So that's the default port. So you either have to type this and type the following URL, or localhost's IP address is 127.0.0.1. So you can either type this as well. Now a note here, and this is something that you might face, if there is any other application that is running on port 5000, you will get an error. So keep this in mind. If you have any applications from any of your previous courses where you developed a web application or a database service or something along those lines, which still uses port 5000, then you will get an error if you try to run this program. So you have to free up that application, you have to close it, and then run it again in order to make sure that you do not get any kind of error. All right. So let us go ahead and run this application. So I will open back my terminal. All right. So let's clear everything here. And we are simply going to say Python app.py. Okay, so you can see this is a development server. It gives you a warning that you should not use this in a production environment. It tells you that it is running on localhost. So this is basically the IP address of localhost. and then on port 5000. And all I need to do now is open my web browser, and in my web browser, I need to type this particular IP address. You don't have to do the HTTP stuff here. You just have to type from the one stuff. So all I will do is do localhost and 5000. Okay, so you can see here, I typed it in a separate window. I know the sharing doesn't show it, but you can see that whatever responses was received, there was a 200 response that was received, which is basically the server code, the backend server code to say that everything was okay. A request was received, and it was able to essentially furnish that web page, or serve that web page essentially. Okay, it also tried to receive like a favorite icon. I'll talk about what that favorite icon is, but it is completely irrelevant right now with respect to the application itself. So that essentially was not found because we have not implemented any favorite icon. It's basically an image that is shown at the top of your browser. So I'll switch the share to my web browser, and we will see what exactly we are looking at, right? What exactly we are working with. So I'll stop the share here, and I will change my share to my web browser, so you can see what is being shown here. So you can see here, I did not type 127.0.0.1 5000. I just typed localhost 5000, which is basically the URL for localhost. This is the login. Why do you see this login here? So I think we don't have to worry about the terminal for the time being, so we can minimize it a little bit. So when I type localhost 5000, this is how it essentially translates that URL. Okay, and remember, in our code, we have a route that once the web server receives this request, then there is a function that will be executed. Okay, what we do not see is, I think, yeah, we are missing one thing though. We can see the enter your password, we can see the login button, but I do not see anywhere the username button. I hope you guys are seeing the same thing as I am seeing. But let's okay, so we need to essentially debug, and we need to check. Okay, I know why it is not working. Why the username is not showing up. So let me fix that, right? So I will have to reshare that again. So we need to switch between windows, and I do not know how I can show multiple windows. I actually do not know that. So I'm just doing it one by one here at the same time. All right. Okay, so the reason I think why the username is not showing up is because, remember how you see here how this tag opens and it closes with this angular brackets, right? You see how this form opens, but it never closes with this angular bracket. So it seems as if all of these content are like attributes of this form and not the actual stuff itself, right? So I have to, I think, close it. And you can see here, if you notice, for those who were noticing, or you can just go back in the video and check, the moment I added a new thing, it restarted the server. So I didn't have to stop the server. I didn't have to restart the server myself manually. So it's a very good process with respect to debugging, right, in a development. So now, if I stop the share here, go back to share, reshare my Mozilla, now you can see my username is back up here, right? So let's try to enter an input. Remember, one of the inputs that we have is Alice and password 123. That is supposed to be the actual input. So if I type, let's say, Alice and password 123, this is the reason why the input type is declared as password, because you cannot see the password. If I did input type text, then you would have been able to see the password that I'm typing. And if we type it, then you can see login is successful because this was already present in our table, right? Now let us try to do something else with this and see how this works out. So we need an injection, an SQL injection parameter here. So let me insert this input to my username. All right. So that means I'm going to type Alice, and then I'm going to create an injection here, okay, with a string, and then I'm going to apply a logical OR operator. Remember, we discussed this in class. So either this is true or 1 is equals 1, which is always going to be true, right? So now if I log in, we need to fill out this field, right? Because we have declared this as required. So let's say I write a wrong password here. So instead of password 123, I'm just going to say test here. And if I log in, you can still see that the login was successful. And this is a clear attack on the system itself, right? So this is basically an instance of the SQL injection attack. So now let's say we give a credential, let's say, which doesn't even exist. Let's try some stuff, right? So what I'm going to do is now, instead of attacking the user field, I'm going to attack the password field, okay? But since you cannot see the password here, what I'm going to write as the password is the same query, right? This is what I'm going to give as input as a password, and I'm going to insert some very random username, let's say, which doesn't even exist in the database. So I'm going to say Delta. We only have Alice, Bob, and Charlie. So we are going to say Delta. And then we are going to paste that password that I showed you in the username itself. So you can still see that even though that username doesn't exist, I can successfully log in through the SQL injection attack. The reason why this is happening, essentially, right? So that shows the demo of the SQL injection attack, essentially. So let me stop the share here, switch back to my VS Studio Code. Okay, the reason why that is happening is because the way we have written the query is as a formatted string. So whenever an input is coming, so that input in the form of something like this, it completely replaces this thing, right? And puts a OR 1:1 here. And if you put an OR 1:1 here, then essentially that kind of bypasses everything else after that, because one of the other is true, and that takes care of this operation. Right? So that is why the injection is happening, because there is no clear separation between the data. So I will write the reasoning here. No clear separation between query and data. And that allows the attacker to insert queries as data input. And when that gets replaced here, essentially that leads to an injection attack. Now, I'm not going to test this command out, but in the username, if I write a query like this, if you can try it out, I'm not going to try it out because that will make me redo everything, restart everything. It's not a big step here, but if I provide this as a username input, okay, if I assign this to the username, then this will essentially delete this entire user database table. By the way, please notice here, once we started the server, this is the SQLite database. This is not a server, this is a file system, but it has a .db extension. This whole thing will get removed altogether, right? So that's a very serious attack. And this is the commented out attack. So what happens is that it takes this, runs this, and then comments everything out after it, which is this part here, right? So that will remove everything that is there. So the question then is, how do you solve the problem? Well, the way you solve this problem is by transforming the query into a parameterized query. So what we are going to do is we are going to comment out these parts here. So I'm going to comment out this one. This is where the vulnerability is. And I'm going to restructure the query, but this time I'm going to implement that as a parameterized query. So that means I will create this query object, and then I will assign this. And there was a syntax error and then it broke out of it. Then we have to restart the server, but that is fine. Okay, so we can remove the terminal for the time being. Let's see. Yeah, okay. So now we need to write it as a parameterized query. So what I'm going to do is I'm not going to write it as a formatted string. I'm going to write it like something like this. So we will say select star from users So users is a table name, so that will be small hand. Where WHERE. Okay, where username, so that's the attribute name, is equals to question mark. This question mark character will get replaced, and password is equals to question. All right. So after this, we will still have cursor get db cursor object has been created. But when we execute the cursor, we don't pass the query as is, right? So we pass the query, okay, but we pass the user input data as input parameters to this execute function. So that means I'm going to separately pass username, and this is the username that has been unpacked from the user request. And then I'm going to pass the password, which is also unpacked from the HTTP request and stored inside this variable. So now this whole thing will be treated as data and not a part of the query. So if I or the adversary tries to inject some malicious strings, it will not be treated because it will look for the data within the database itself. So it will treat the data as data and not a part of the query, like we did here in this commented out line 84. Okay. So let me see. Yeah, everything looks good. So let's open our server, our terminal, rerun our server. So we'll just going to do python.app.py, and then we will stop the share, and we will switch to our web application, right? So we will go here, we will share, and I will share my web browser. All right. So now if I run this delta and whatever this password was, right, we can double check what password we are giving here. So I'll just paste it here. Okay, so that's basically the drop table command I'm running. Hopefully this is going to be unsuccessful. Otherwise, I'm in big trouble. So we are going to log in, and you can see here it says now invalid credentials. It didn't drop the table. It actually gave the fact that it is invalid credentials. So if you try one of the previous commands that we tried, right? So that means if we have the username as something like this. Let's say we put Alice or one, and we don't know Alice's password, so which is password 123. So we will say test 123, something like this. We don't know their password. All right. So we are trying to inject it. So if we do this, it's going to return invalid credentials because no such username exists in the database. And if we provide the actual user database, only when we do that, so when we provide Alice and then the actual password for Alice, which is password 123, and when we try to log in, that is the only time the login is going to be successful. Okay, so that is basically a demo of SQL injection attack. So let's do a quick summary. I know this has been a longer video compared to our previous ones. So let's stop the share. Let's reshare the VS Studio code. Okay, and let's do a quick summary of what we have learned to implement in this application. We have actually covered quite a bit. If we consider to be at a beginner level, we have covered quite a bit. All right, so we'll stop the server here. We don't need it to start jumping around. So I'll just hit a Control-C and it will stop the server. And then I will remove the terminal. Okay, so let's summarize what we have learned real quick. So we have, from a programmatic perspective, we have learned to implement a minimalistic, full stack web application using the Flask Python framework and SQLite library. Okay. SQLite is inbuilt, so we didn't have to install it. Flask, we had to install it, but we faced some errors due to administrative privilege. So we ran it in user mode, and that hopefully resolved. That was the reason why the issue got resolved. But yeah, we will never know. Okay. We learned about some of the key components of Flask. So that is with respect to its syntaxes. All right. We learned about how to write and execute SQL queries in Python. Sweet. and we learned, we demoed of SQL injection attacks and how to solve it with a focus on separation between query and data. Okay, so what we call it is basically the parameterized query. So that is basically the outcome. I know we covered more than this, but I'm not going to summarize the sub points of it. So please practice this, and I will open a new assignment for this in Moodle. So submit your documentation as well as the snapshot of testing this particular code. So here the snapshot won't be of your terminal only. It will be a snapshot of your web browser where you run this code, because you essentially have to show step by step that your application runs, and you can show it. And then if you try to run it, you are able to successfully attack it or unsuccessfully attack it and stuff like that. So I will include those instructions when I upload the assignment on Moodle. But in the meantime, please practice this. It's an interesting thing to learn. And I will see you all in the next video, and hopefully we will talk about either firewalls or port scanners in that other video. Right? So till then, take care and bye-bye.